Okay, here we have a question about traveling waves. We're told amplitude and wavelength. Take a second to read the question and then watch on for the explanation and the answer. All right. I think this is one of these ones where once you see the answer, it's fairly straightforward. Okay. The best thing to do, in my opinion, is to have a vision or an image in mind of what a transverse traveling wave looks like. Now, on there, what you can see is the displacement, and it's plotted along a distance in the direction of travel. Now, we're asked what the minimum distance between a trough and a crest and a trough are. So you should be aware that a crest is the maximum, a trough is the minimum. So we're looking there. And hopefully what you can spot there is that is half a wave. That distance between the two is half a wave. Now, I think the bit that people get a bit confused there is which directions are we looking at here. Our x naught is a measure of amplitude, and so that's going to be vertical. So those two answers, A and B, are not relevant here because they measure the displacements. What we're interested in is a distance in the direction of travel. So our answers here are either wavelength or wavelength over 2. As we've said, half a wave between the two. And so therefore, our answer is lambda over 2. Now notice there is the minimum distance. You could have a question where it says, what is a possible distance between the two? Okay, and it could be, for example, 3 lambda over 2, where you've taken the distance between, for example, this crest and then this trough. Okay, so this question's a bit simple. However, I can see that it could become more complicated when you consider the relationship between other crests and troughs. Okay, hope that's clear. Thanks for watching.